Hello ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today we're going to be going over the 5 main types of reactions, so follow along with your notes, and if you have any questions, make sure to bring those tomorrow. Alright, so the first type of reaction is called a decomposition reaction, and so decomposition is exactly what it sounds like. It's when a substance breaks down. Now it can be due to many things, but normally it's due to heat. So the general formula for any decomposition reaction looks like this. So it's AB, so two things sort of put together, yielding two separated things like this. And a good example of what that would look like is right here. So we have HGO breaks apart into Hg and O2. So when we balance this equation, we end up getting the following result. And so this is a really good picture of kind of what that process looks like. So we have water breaking apart, making hydrogen gas and oxygen gas. We have our symbols, and we also have a nice little picture of what that looks like. The second type of reaction is called a synthesis reaction, and that is when two or more substances combine to form one product. And so the general formula for that looks like this. So we have two separated things as our reactants, and then we're combining them to make one thing together. So here's a very good example of what a synthesis reaction really looks like. And so we have N2, nitrogen gas, and H2, hydrogen gas, yielding NH3. And so we also have two pictures of what synthesis reactions look like, and they're both good. So again, underneath here we have our symbolic representation, and then up here we have our pictures. And so you can actually see, we have 3 magnesium, and we have 1 nitrogen molecule, and then when we put them all together we get Mg3N2, which is magnesium nitride. Again, just giving us a different way of looking at what synthesis reactions are really all about. But anytime you start with two separate things and you bring them together to make one, that is synthesis. All right, the next type of reaction is a little bit more difficult to recognize, and it's called a single displacement reaction. It's when you have a single element and it replaces another in a compound. So our general formula looks a little bit more complicated, but it really is if we have a compound that has two things in it, and then we have an element that is by itself. That element by itself will replace something, and so I'm going to use a different color. The way that I often represent that is like this. So these guys switched spots. The X and the A switched spots, and that is a single displacement reaction because only one thing is switching spots. So what does that look like practically? Well, practically, this is an example of a single displacement reaction. So we have magnesium, and we have copper 1 chloride, and then as you can see, magnesium and copper are going to be switching spots. So we end up with magnesium chloride and copper metal by itself on the opposite side. So here are a couple of just visual representations of what a single displacement reaction looks like. This is just sad, but we have a couple, and we have a new guy, and then this guy replaces this guy. So now we have a little loner all by himself over there in the corner. Another way of looking at this, we have zinc and we have hydrogen sulfide. So zinc is replacing the hydrogen, and now we're left with just hydrogen gas and zinc sulfide. Now this one, again, if you understand what a single displacement reaction looks like, a double displacement reaction is just 2. So instead of one element replacing another, we have 2 elements or ions. Sometimes it can be ions. In fact, I think most often we'll kind of see that. They swap places in a compound. So again, what we're looking at here is a general formula which looks something like this. So I'm going to rewrite that. XY plus AB yields AY and XB. Okay, and so as you can see, I have X and A, all right, which are switching spots, and then I have B and Y, which are switching spots. So I actually do end up with a swapping of 2 different ions in that situation. So I decided to give 2 examples of how double displacement reactions work because it might be a little bit easier to see it if you actually have 2 real good examples. And so we have silver nitrate and we have sodium chloride. So notice on the opposite side here, I'm making sodium nitrate and silver chloride. So I have two things that are swapping spots. I have my Ag and I have my Cl, which are pairing up. And then I also have my Na and my NO3 pairing up. Okay? And in case you're wondering why it's NaNO3 and not NO3Na or something like that, remember we always have our positive cation first and then our negative anion second. So make sure that you are actually writing these in the proper order when you start to pair things up. Here's a second example. So I have zinc nitrate and I have sodium sulfide. And then I have zinc sulfide and I have silver nitrate. So notice again, I drew these in already. We have a pairing up of zinc and sulfur, and we have a pairing up of sodium and nitrate. So to follow along, we have, sort of this picture. It really is, again, two people or two things that are swapping positions. So we have these two pairing up, and we have these two pairing up, and that's an example of a double displacement reaction, or at least a visual representation of a double displacement reaction. The final type of reaction is called a combustion reaction, and it's probably the weirdest one because it has a very, very particular formula. And so combustion is basically anytime we have a carbon-based compound and we are burning it in the presence of oxygen. And when we do that, we always produce CO2 and water. So the general formula looks totally different. This is the general formula, all right? X has to contain carbon, and then we have O2, and we yield CO2 and water. Okay, so whenever you see a carbon-containing compound, it does have to have carbon in it. Okay, it can't just be some other random compound. It has to have carbon. And you see oxygen, and you're making CO2 and H2O, that tells you it's a combustion reaction. Okay, again, combustion is very, very particular. And so a really good example of a combustion reaction is right here. We have carbon tetrahydride, or methane, and oxygen mixing together to make CO2 gas and also water vapor. Okay, and so anytime we are like burning something, that's going to be a combustion reaction. And so in this situation, this is what we did on the very first day of class. When I set some hands on fire, this is the actual chemical reaction that was going on. It's methane and oxygen making carbon dioxide and water. And that is the end. So make sure you bring questions if you have any tomorrow, but those are the 5 types of reactions.